In this lesson, we will investigate the limitations and procedures of all-weather operations, specifically low visibility procedures, LVP. As such, this lesson assumes a fundamental knowledge of instrument departure and approach procedures and will refine that knowledge based on how airline operators conduct IFR operations. First, we must define low visibility procedures. They are aerodrome procedures to ensure safe operations when non-standard instrument approaches and departures will be conducted. These non-standard instrument procedures are during lower than standard Category 1, other than standard Category 2, Category 2 and 3 approaches, and low visibility takeoffs. Standard instrument procedures are non-precision approaches, Category 1 precision approaches, and departures when the visibility is 400 meters or more. Non-standard instrument procedures are other than those mentioned. A low visibility takeoff, LVTO, is one where the runway visual range, RVR, is less than 400 meters. Here are other useful terms. First converted meteorological visibility, CMV, which is a value, equivalent to RVR, derived from the reported meteorological visibility and converted in accordance with the requirements in EU OPS. GNSS means a global navigation satellite system, such as GPS or Galileo. The GLS, Global Landing System, is a type of instrument approach procedure that uses the GNSS technology. A lower than standard Category 1 operation is a Category 1 instrument approach using the normal Cat 1 decision height, DH, but with an RVR that is lower than normal. The other than standard Category 2 operation is a Cat 2 instrument approach where some or all of the elements of the required lighting system are not available. Next, we will examine the terms for conducting the approach. Owing to their size, weight, and proximity to the ground, airliners on approach, whether precision or not, should be flown in a stable manner where events, flap settings, gear down, speed, and height adjustments, are undertaken to maintain a precise and carefully controlled environment. Many operators use the stabilized approach technique, where the parameters for events on approach are strictly defined and with the requirement that a missed approach be initiated should the pilot exceed one. This technique has evolved into the continuous descent final approach, CDFA, where a non-precision approach is flown as if it were a precision approach, and down to a decision height such that minima are not infringed should a go-around be the decision. If the decision is to continue, the aeroplane should already be in an appropriate position at the correct configuration to smoothly transition to a landing. Here are the definitions for the stabilized and continuous descent final approaches. Our next group of terms relate to the type of flight control system, and for the purpose of this subpart, a flight control system means a system which includes an automatic landing system and/or a hybrid landing system. The difference in the systems is what happens when the automatic landing system fails in the late stages of an approach. Basically, a fail operational system will complete an automatic landing, whereas a fail passive system will require the pilot to take control. The hybrid system requires the pilot input but will give the necessary guidance to complete a landing. Here are the relevant definitions. The final group of terms relate to aids to completing an approach visually. Here we will consider the head-up display, the HUD, and the Enhanced Visual System, EVS. A HUD will project flight information onto a transparent screen in front of the forward cockpit window, such that the pilot can see vital flight information while also looking ahead for the specified visual reference to complete the approach. This system minimizes head movements and also reduces the chances of becoming spatially disorientated. The EVS does more. It uses imaging sensors, infrared, low light, etc., to produce a picture of the outside world such that the pilot can complete a landing visually or circle to a visual landing. To complete this section on terminology, here are the terms relevant to HUD landings and to visual landings. Click on a term to get its definition. It is probably obvious that in these most complex and potentially hazardous of operations, the national authority is very involved in system and procedure certification. The operator, meanwhile, must establish LVPs in the operations manual, which include the training and qualification requirements for the affected flight crews. For Category 2, 3 or other than standard Category 2 approaches, the authority must certificate each suitably equipped aeroplane and approve the operation. The operator must establish a system for recording the success or failure of these approaches. The other requirements are that the aeroplane must be operated by 2 pilots, even if it is certificated for single pilot operation. And it must be equipped with a functioning radio altimeter to monitor the late stages of the approach. For lower than Category 1 operations, the authority need only approve the operation. Certification is not necessary. Nor is the requirement for a radio altimeter. Nor 2 pilots for an aeroplane certificated for single pilot operation. Similarly, authority approval only is needed for low visibility takeoffs, LVTO. The limitations are a minimum of 150 meters RVR for Category A, B or C aeroplanes and 200 meters RVR for Category D. Additionally, the aerodrome must be approved for these operations as well as able to enforce the procedures when they are required. Finally, of course, each flight crew member must be trained and qualified to conduct these specialized operations. Here are the flight crew training and qualification requirements. As mentioned previously, the operator must establish LVPs in the Ops Manual, including the duties of flight crew members during taxiing, takeoff, approach, flare, landing, rollout and missed approach, as well as the minimum aeroplane equipment requirements. As far as the commander is concerned, he must ensure that, before commencing an LVP, the facilities are adequate, LVPs are enforced at the aerodrome, the crew are qualified for the operation, and the aeroplane is suitably equipped and certificated for the operation. Now let us turn to the other end of the spectrum, that is, operations under VFR and Special VFR. Special VFR flights must not be commenced when the ground visibility is less than 3 kilometers, nor must they be continued when the in-flight visibility is less than 1,500 meters. The VFR minima are shown in the table on the screen, with which we complete the lesson on all weather operations.